popular. So we'll go to the first technique, feed forward technique. It is very simple. The main power amplifier you have, an output of power amplifier, you take it, sample it, divide by 1 by AV, input, and that one you subtract. So whatever error signal you have, you again subtract that from your main power amplifier. That is going to be the output. Feed forward means in the forward path, I am going to have a feedback network. Feedback is usually from output to input, right? That is not the case here. In the forward path, I'm going to have a separate feedback path to subtract my error signal. So you can see here, if at all any error, I am comparing the output of power amplifier divided by AV with the input, and any error that is amplified and given here to this adder, and amplified signal will be coming here, and both will be removed to give you an error-free output signal. Okay, so I can write if you see the mathematics, what is the voltage at point M? I can write Vm equal to V in AV into V in plus VD. Assume you have a distortion. VD is a distortion. And at the point N, I'm going to divide the Vm by AV. So Vn will be equal to Vn plus VD by AV. You see here, the distortion is divided by AV. The distortion level on the correct. And what is the output at P? P is equal to subtract minus V in. So when you subtract minus V in, V in will get cancelled. So you will just have VD by AV. And finally, what is the point? What is the value at this point Q? Amplify that by AV. So VQ will be equal to AD. Finally, what is V out equal to VM minus VQ? So what is VM? AV, V in plus VD. What is VQ, VD? Subtract, you will get AV into V in. So output is perfect amplification of input. This is one feed forward technique. So in practice, this is the basic structure, and they have modified this to have one more. They have modified the structure to have one more amplifier here. So I'm going to have delay delta 1 inserted in the input side and delta 2 at the output side for the phase shift of the error amplifier. In case amplifier amplitude wise it is getting reduced. In case I have phase shift now, I can account for that by introducing one delay in the input side, one delay in the output side. So the two paths from V in to the first subtractor is called signal cancellation loop. So this path is signal cancellation loop, and this path is error cancellation loop. So two paths are there, and when you use both the paths, output is will have only the input voltage, and all the distortion is going to be completely cancelled out. So this has several shortcomings when you fabricate this power amplifier, because whatever delay you give, that will reduce the performance of your system. So you can see that the efficiency is only 22%. So the third, the linearity improvement, this depend on the gain and phase matching of signals. The subtractor has to work properly. The subtractor is not working properly, then there is no use designing this network. And error, the error value is given by this one, how much error you have in the signal. So it is 1 minus 2 into this formula. Delta A by A is variation in the amplitude, and delta phi is the variation in the phase angle. So if you substitute, you get the error value as 0.102, approximately 20 dB. They say the 20 dB IM products are there in your signal.